Hello, everyone, and welcome to our live stream, aka podcast, because we do turn this into a podcast later. So, as always, delighted to have you here, and we do want to make you part of this conversation. So, please feel free to add your own questions as we chat with today's fabulous guest, the amazing Chip Huyen, and we're going to be talking about her new latest book, AI Engineering, which was just released last month. But a few quick housekeeping tasks. I just want to let you know about ODSC East that's coming up because today is the end of our early bird special. So as you know, ODSC East, this is our 10th year in-person anniversary. We've been doing these conferences for many years now, and we are definitely staying current. So we're looking at another fantastic lineup for May 13th to 15th in Boston. You can join us in person. We'd love to meet you there. Lots of amazing speakers and instructors. And we will, of course, have a fantastic lineup. And if you've been paying attention to our emails and our website, you know we've already announced we're calling it first 40 speakers, but it's actually more like first 50. So go do check it out. Our best price is available there and would love to have you join us. Also, speaking of summits, we're doing something else that's getting quite a lot of traction, especially last week. We are doing a virtual training summit, and it's actually running over 4 weeks. So if you are a seasoned practitioner, you may already be very well versed in LLMs, RAG, AI agents, reasoning. It's the latest thing now, and just building things. But this is starting next week. It's running virtually. It's 2 or 3 days a week. And we, again, have some amazing speakers lined up for that, such as Sinan and Ed Donner. And this is an excellent chance to get deep into the weeds of large language models, retrieval augmented generation, AI agents, reasoning. And the final week, we're going to have some very cool builder demos. We're calling it our AI Builder Demo Day. And these are definitely not going to be product pitches or platform showcases. And rather, it's like, how do I build an intelligent chatbot in 15 minutes? How do I build a QA system? How do I do research and build other tools to help me interface with my agentic workflows? So an amazing week lined up for you there, and hope you can join us for that. And also just started this week is our AI Bootcamp. So if you are new to AI, you want to go on from the very start to the end of your AI journey. We're running that over 6 weeks, so you can get much more well-versed into the content that's coming up on ODSC. So go check that out as well. That also has an early bird ending Friday. But on to the main event. So Chip Huyen has been a regular speaker at ODSC, and I believe she did keynote it a couple of years ago. And we're very, very happy to have Chip on the show today because I got to say, Chip is one of my favorite engineers. I follow her work. I was following the draft of her book that's going to be the subject of today's conversation, AI Engineering. And when I saw the final version, which I got to a little bit over the holidays, and I just kind of wrapped up a read over the last few days, I was pretty much blown away by it. So really, I think this is going to be a great conversation. So let me welcome Chip to the stage.
Hey, Seamus. Hi, everyone. Thank you so much for having me here, and thank you so much for the kind words. I was blushing in the backstage, so thank you.
Those words are very well deserved because the breadth and depth of this book has been amazing. I could not believe how comprehensive it was because as someone who has to, for my other roles, building out some of these agentic AI and LLM and RAG stack, I could not believe how much you packed into this book, from prompt engineering to generative AI to the dataset engineering. It was a fascinating read. But anyway, I'm getting ahead of myself, Chip. We'll get into the book later. But first, Chip, I want you to introduce yourself to our audience. Tell us a little bit about your background and maybe some pivotal or key moments in your career.
Yeah. Hey, so I'm Chip. So I have been very lucky to be able to speak at ODSC a few times. Thank you for inviting me, and I always have so much fun at the conference. And yeah, so about me, for key moments, like how far back are we, going? Are we going? Like, do you want to start with like a
Up
stormy
to you,
night when we
Chip.
were born?
We can
Yeah,
always edit it out later.
yeah. So let's see. So I actually started doing competitive math for a long time. And I think
Oh,
the
wow.
first pivotal moment and the first existential crisis was when like I was in 10th grade, going on 11. And I had this like question in front of me. It was like, what happens is like with math, like I really like math, but like what am I do? Like when I get to college and like school, is this gonna be something I do forever? So I decided to like stop doing math and then I switched to like writing. I was very fortunate to have like opportunities to work with some really good writers and mentors who were like teaching me in the craft of writing. And then I went to college, thinking I would do major in creative writing. It was when I read this paper, like Alex Net paper. It was very okay, sorry. I read the paper later, but like I took a course in AI, and then it was a lot of fun because I do think that education is really really important in shaping a person's future. So I was thinking of doing script writing, but then I took this like AI course, and it was like I was able to like write games and like how to make games more fun. I was like writing like algorithms for the Pac-Man to win the game, or like making games and make it really hard for
Nice.
like friends to win. I was like, wow, like it's so fun. So I decided to major in AI, and then I read this paper, like Alex Net paper, and there was this like throwaway comment in the paper. It was like I don't think people paid attention to it back then. It was just like, on our experiment, show that we will get better results by just waiting for better GPUs and bigger data set.
Right.
So in my head, it was like, okay, so two things are important. This is like compute and data. So my first job after college, I joined NVIDIA because I thought like where else better to learn about compute. And then after that, I
I hope they
joined
gave you some good
another.
stock options. Anyway,
uh, yeah, I think I was very I was pretty lucky with NVIDIA. And then but not as lucky as the people who used to stay at NVIDIA until now. I feel
mm,
like a lot of my friends who joined the same time as me and they stayed the last like 5 years, 6 years. Um, okay, so and then after that, I joined a startup working on waste supervisions for data labeling, and that was like a lot of fun. And then I started my company, and then I sold the company last year. Now I'm just like unemployed.
congratulations.
Thank you.
Very nicely done. Yeah. So, as mentioned, the subject of today is AI engineering. I actually gave a webinar myself last week on top skills of 2025. It's also on AI Plus where we have these recordings. And it was amazing to me how the role of AI engineering had grown fit 100% actually in the last year in terms of, well, it was a very quick study on LinkedIn, how many people have the role of AI engineering. And we track it year to year. And I noticed that it increased over 100%, I think I think it was 4,000 or 5,000 for the US anyway. So Chip, the key question is, because people always ask me this, what is AI engineering, right? Especially for those of us who are already data scientists, machine learning engineers, data engineering. What is AI engineering and how has it emerged as its own distinct discipline within the AI landscape?
Yeah. So this is actually a question that I agonized over for a long time. It was like, how should we name the book? So there
Yeah,
were like a lot. So one thing was clear is that like, even though there are a lot of things that haven't changed about working with machine learning models, a lot of things have also like arise with the introductions of foundation models. So for so so I see like a lot of companies, like people working with classical machine learning models, like for detection, spam classifications, and people working on generative AI applications. The same team. I just grab it like ML team. But we still want to see like I was also going through LinkedIn and like other job posting, and I see a lot of people looking specifically like people working on generative AI foundation model. So I guess the key difference is that like with classical machine learning engineering, you build the models yourself. And with working with foundation model, you use some existing models and you build on top of that. but I think it's like in a lot of systems, they're not mutually exclusive. In the vast majority of generative AI applications I have seen, classical machine learning is actually being used together with foundation models. For example, like if you build a customer support chatbot, so like you have the request from the customer, and then you want to like send it to the right model. Maybe you have different models with different price range, or like you may have like human in the loop, or you might just want to like pull out the answers from an FAQ because the question is simple enough, right? So you might have like an intent classification model to determine the intent of the request before routing it to the right solutions. Or like after the model generated a response, you might want to try like, hey, does a response contain private info like PII or like sensitive information? So you might want to build some like classifier to detect that. So I don't think it's like an and or. It's just truly like you likely if you are building some system to address like complex real world problems, it would likely need both. I think I can't hear you.
Yeah, I love that, Chip. I really think that those are very valid points. And like you, when I was looking at those roles on LinkedIn, I was very curious as to who was doing rather what if you could tell, because sometimes people describe what they're doing for various tasks and stuff like that, and sometimes it seems like it's a more of a generative AI role than an AI role. But I think and your book did a super job of laying this out. And you mentioned at the very start about scalability and compute, right? I really
Yeah.
think that AI engineering is, as you said at the very start, it's about scaling and compute. And for myself, I'm really excited about the role because it to me it does, because I used to complain when I used to work as data scientist or hire data scientists that their software engineering skills were very poor. So again, no offense to anybody. I know we've all improved in that, but to me, AI engineering, like machine learning, takes software engineering very seriously. It has elements of data science, has elements, a lot of elements of this kind of system design, and it's got this great multidisciplinary approach for this complex AI system integration that I found fascinating. And really, from reading your book, I learned some more skills there. But bringing up the point of generative AI again, which you mentioned, is interesting because that field has been moving so fast. And how did you deal with the angst of writing it? Because you just said it like you had angst over the title of the book, and I can guess some of that must have came from the fact that AI and generative AI was moving so fast. And I don't know the time scale you wrote the book over, but 2024, like, look, like, so how did you manage to
Yeah.
write that book given it the fact that everything was changing so fast?
Yeah, it was definitely like a little bit of like very nerve-wracking, anxiety-inducing experience. So, yeah, so I actually like have been pretty okay. So I don't want to be one of those people like when I came out and start saying like, oh yeah, I've been doing this for a long time, I did that. But I'm actually pretty bullish on language modeling for a while because I started with AI and I was so I started with like NLP, natural language processing, working with like machine translations and language modeling. And I remember like in 2017, I was just like going through like my notes in the like anything that had a language modeling in the past, and I found that like I actually had a poster at NeurIFS in 2017, not a main conference, just a workshop. And it was about like using AI to evaluate the quality of translations without reference data, which means like using like a language model as a judge. And I remember the conclusions I had was like, okay, we need better and bigger language models. And at that time, everyone was telling me like, oh, you're definitely crazy. Like, no, we will never get to the point where AI would be good enough to be used as an evaluator of like AI responses. So because I was following it for a while, and I feel like with a lot of people who have been like following the field, it's not a surprise to see the progress in the AI capabilities. So what was surprising to me was that like I had thought that a small improvement in capabilities of AI models would result in like a small increase in the number of possible applications, but I was wrong. Like somehow we reached the tipping point of like, yes, we have been like steadily increasing the capability of models, but then suddenly now it enabled an explosions of new applications. And that is like so incredibly exciting to see. And at the same time, we see that like because the models are now accessible by like everyone, like everyone now can just like build application on top of them. And the
That's
energy
right.
is absolutely insane. It's like so exciting. But it wasn't always exciting, right? I think like when ChatGPT first came out and I saw like so much excitement and so many applications, I was in a group chat with a bunch of my friends. And it was just like, oh my God, what are we doing with our life? Like we just like have this moment of like existential crisis. And then a friend who was a very experienced and a really respectable researcher who has been in the field way, way longer than me. And he was like, I felt listless like for a month because it's just like there's so many new things and I just feel like questioning our research and like stuff like that. So I decided to like interview and I talked to as many people as possible and like just making a lot of notes and then I started like going into like really deep into papers and like frameworks, going into like code
Yeah.
bases of different things. And then I had a lot of content for it. And then I was like, okay, I have so many materials, I did so many interviews. Maybe I should write a book of it. And then Seamus, like you said, it's just like the future is moving so fast. Like, is now a right time to write a book, or like should we wait in the future? So I realized something that even though like a lot of new applications we have today, the building blocks of foundation models or like the engineering best practices like have been around for a long time. So for example, language modeling, right? Like it was introduced back in the 1950s by like Claude Shannon. So it's not exactly new or like people are today very excited about like RAG, like retrieval augmented generations. So a lot of this is building on retrieval. And retrieval is not a new technology. Like, it's been powering like a lot of
Right.
application on the internet, like web search or like recommended systems. So people coming from a Rexis and search background actually have a huge edge in like looking at a RAG system. So it's not new. It's not things that like writing is like sometimes feels like making a bet. Like you bet like by choosing to focus on a topic, you're making a bet on whether this topic will remain relevant in the future, also become important in the future. And a lot of things changed over the last 2 years. And some of the changes actually helped me feel more confident, like more validations of like what I thought would be like important. So for example, I wrote about multimodal I had a blog post about it like maybe like over years ago. And at that
Yeah.
time people was like, oh, you're too early and like we're still like dealing with like language. But then like it's multimodal is just like the default, like for a lot of like models nowadays. Or like AI as a judge. Like I think
Right.
when ChatGPT first came out, it was like, okay, AI is too unreliable to be entrusted with such an important task of evaluation. But now it's just like a lot of people are using it. Like AI as a judge is like it's actually a very big components of a lot of evaluation systems nowadays. So like just things like that, or like something I can go on and on, but I feel like maybe I should probably stop here.
No. And look, it was just published in December, fully published, and I think it's very current. I just have it up here in front of me. That's why I keep looking to my right, your left.
Yeah.
And no, it's an amazing read. Like especially, I found for me personally, I still believe prompt engineering is a misunderstood discipline, which we'll get to that a little later.
Yeah.
But I found it very up to date. So I was really surprised by that, like how current it was, and I love the little all the nuances you put in there. Um, like you have the Shogot image, which is that what is that? That amorphous creature from H.P. Lovecraft. That was a viral meme for people who know what I'm talking about. There was this meme out when ChatGPT came out, at least 4.0 came out. People had that existential crisis you mentioned, Chip, where
Yeah.
they felt like it was going to consume everything, and it put a little smiley face, and the smiley face was the chat window, and they felt it was going to consume everything. Like first it was software eating the world, then it was AI eating software, and then it was chatbot, then it was ChatGPT eating everything else, eating AI and machine learning. But did I hear you right? Did you say you had an LLM as a judge paper at Europe's in 2017?
It's not as a main conference, it's just a workshop, a new
Oh, yeah, workshop.
workshop.
Yeah.
Yeah,
But no,
yeah,
I go to Europe, so I know it. But
yeah.
wow, I never even knew the concept of LLM as a judge or AI judge until 22 at the earliest, maybe even 2023. So yeah, So I get it. I hear what you're saying, because researchers like yourself um, uh, were really tuned into a lot of these techniques that they weren't ready for production yet. So practitioners like myself, we're learning about these later on, which is good because we don't have time to be researchers. So yeah. So again, once again, very impressive there. So
Thank you. I just want to say it's like I don't want to. Okay, I don't want to call myself like a researcher like myself because I feel like there are a lot of researchers way better than me. I'm like do research very lightly, and I think that
yeah,
research is incredibly hard, and I have a lot of respect for able to pursue research.
yeah.
I don't do as much research to like call myself that yet, but yeah.
Okay, no, but I think that the quality of work you put out, Chip, is top notch. So, um, just looking again to cover a few high level questions here before we get more into weeds. I know we talked about the role of engineering, but to a lot of people, it's very akin to machine learning engineering. Can you talk us through a little bit about how AI engineering is different from machine learning engineering? And again, the reason why I asked that question is I'm not so much looking for, hey, I want to be an AI engineer and what's wrong with being a machine learning engineer. It's almost like understanding the discipline, the role of that, and what that encompasses. Because at the end of the day, we all end up doing a little bit of ML engineering, a little bit of data engineering, a little bit of data science. So how they differ can kind of help us understand the nuances of those various tasks that an AI engineer or machine learning engineer would do. Yeah. So how is AI engineering different from machine learning engineering?
Yeah, I actually get asked these questions a lot, and the thing is, I must admit, it's like even though I love writing, one thing I really don't like is writing definitions. So if I try to define anything, because no matter what you write, define, people gonna get someone's gonna get upset. So disclaimer before I go into the difference between AI engineering and ML engineering is that the terms like can be very flexible. So like for example, you can be an ML engineer as a company. It's gonna be very different from like ML engineer at another company, or even the same company, people with the same role can do very different things. So like all of this is like really just approximate like overall high level. So it was just like how machine learning, how AI engineering differs from ML engineering. So I would say AI engineering evolves out of ML engineering because they share a lot of foundations, fundamentals of working with like machine learning models. The key difference is like maybe in ML engineering, there's a lot more machine learning, and like there's a lot more buildings, developing the models. Whereas with AI engineering, you actually use existing models and then adapt it to your needs. So there's a few key differences that arise from this. So like the first one is that um, because it's like a lot of the models I just keep coming up. So a lot of models, foundation models or generative AIs that AI engineering uses, they are very they are open-ended, they are very smart, and they are a lot harder to evaluate. So evaluation has become way, way more challenging and more important. So I say it's like it's smarter, like the smarter a model is, the harder it is to evaluate it. So imagine this like a lot of us can tell whether it's like the first grade math solution is wrong. I hope that most of us can. But very few people can tell whether like a match PhD level questions or answers is like wrong. Like it's like still harder, the more intelligent,
Right.
the more complex, it's harder for us to like tell. The second is that like open-ended natures of generative AI actually make it really hard to evaluate. So before a lot of the models that we use were like fraud detections or like spam classification. So we know that, like the output can either be like spam or not spam, right? And then if we notice like the exhibit output is like spam, but the model output is not spam, then we know that the model is wrong. But now let's say just like the model, you ask the model to summarize a book. The summary sounds reasonable, right? Like how do you know that is correct? How do you know that's a good summary? You might have
Yeah.
to go in and read the entire book to determine. And I think it's like also like generative AI, like with the models sound very coherent and very convincing. I think there's several studies saying it's like the more stronger, the more powerful the model, the more convincing it is in like presenting like
Yeah.
not true arguments. So like
Yeah.
let's say
Hallucinating.
like
Yeah.
yeah, so like, I'm a saying user and I ask the model AI something because I don't know the answer. And the AI respond with something like very convincing. And because I don't know it already, how do I know that it's like it's wrong? Like it's just like it's just really a little bit like scary and like because of these silent failures. So evaluation is become like incredibly more challenging. And the second thing is maybe it's like more of like both a skill set and organizations aspect. Is that before if you wanted to build like an AI ML application, you had to build a model so that only the companies, the organizations that have resources to build models can build applications. So a lot of this AI ML products application would build in. So first of all, recommender system will be part of like Amazon system or like Twitter, right? Like I don't just go out and build a recommender system because I wouldn't have the data. I wouldn't be able to deploy it. But now it's like people can just like take it and build applications. So now we have a whole new way of like deploying applications that's not tied to like any specific product. So the whole world of like AI interface and have to really understanding building like AI product, how to extract the feedback from users, to improve the systems, improve applications. So I think it's like in a way, it's like AI like engineering is moving closer to product. Like in the past, right, you start with data, you build model, and then only after that you like put in some product. But now like a lot of time you build a demo first and think, okay, what's the product I want to build? So you build that so like product first, and then only if it's good, it's like, okay, let's start getting more data and improve this. And then only after that you go and build a model. So like product is extremely important nowadays with AI engineering.
Yeah, and Chip, again, looking at your book, because I love the point you mentioned about evaluation, because that's actually your chapter 3 and chapter 4 of your book. The first chapter 3 is about evaluation methodology, and the next chapter 4 is about evaluating AI systems. And I actually know we have a couple of good questions from our audience, but let's just go into evaluation a little more, because I think that's so important to cover, because you already talked about the open-ended nature of AI. Um, that's a challenge, right? And but there's a few things that you mentioned in your book, which I was a little familiar with, but not as familiar as I thought it was. Like, um, yeah, if you can talk a little bit about what makes evaluation hard, especially for AI engineering, because you mentioned some other challenges out there in your book, like the data flywheel, and the fact that AI engineering is not necessarily generative AI or classical machine learning.
Yeah. So actually, when I just started with the track, I was like, okay, let's just have a chapter on evaluation. I was like, oh my God, this topic is so big and it's so important. It ended up being like 2 very long chapters. So one very interesting things that I thought about quite a lot during writing is that like before, like early on, we thought of like humans experts as the gold standard for the models. So like we say, okay, if a models can output can generate outputs similar to human experts, then we consider those models good, right? And they have like human experts to evaluate those model. But now a lot of us are using like AI for tasks. It's like way more like beyond our capabilities for those tasks, right? So the question arises like, how can we like evaluate models that like are putting things that, like way more complex than what we can do, or we come comfortably doing, or it can do so like more efficiently than us, right? So I thought about it's like so I started thinking about like different approaches, because different approaches like to get there. So one thing is that like one approach is like functional correctness. So that means that you evaluate the output of a model based on like how well it performs a task. So let's say you ask the model to like save you energy. Then you can evaluate how good a model is just by like how much energy it saves you, right? So like it's very common with things like coding. So like I don't think it's a coincidence. It's like coding is one of the most common, like most popular use cases of generative AI, because like coding is one of those, okay, when the output is open-ended, but you can evaluate the quality of the code based on functional correctness. So you
Very
have
good
the code,
point. Yeah.
yeah, and you can see if it compile, whether it outputs the expected like outputs, and then how efficient it is. So it's very cool. I think it's like if you can evaluate the application and with functional correctness, you should do it. The challenge is that like maybe AI, a lot of AI is not quite good enough for a lot of applications to do it end to end. So you use AI for only a subset of your task, right? And it's harder to evaluate just part of the task than the whole task end to end. So the example is like a chess game. It's a lot easier to evaluate like whether you win or lose a chess game by the end of it, right? But in the middle of it, it's really hard to evaluate like, okay, how good each move is. So I think like I do think that as AI becoming more powerful, then we would be able to evaluate a lot of more things with functional correctness. So the second approach that I see is just like AI as a judge. I think we brought up several things, several times. But I do think it's like, what if we can have AI to train specifically to like help us evaluate? And even though this is like, even though there's still a lot of challenges with AI as a judge, a lot of times it has shown to work like pretty well in, especially in productions when you don't have any other way to evaluate your model outputs. And then another approach is like comparative evaluations. So like instead of evaluating the model output individually, you like have a bunch of outputs and say, okay, which one is better? And I think it's like there's several studies like for humans that like we, even when we cannot give a concrete score, know how good something is, we can still tell whether it's good in like whether it's better than another. Like for me, right? If you show me like a song and tell me, hey, tell me how good this song is, I was like, I'm not a musician, I don't quite know. But if
Yeah.
you show me play two songs, and I'm just like, okay, I like this song more than the other one. So like we can like so like, and this kind of evaluation also very useful to train the model, because a lot of time people say it's like, okay, we want to build AIs that align with humans' preference, right? Align with what humans want. So this kind of signals can actually be very, very useful to like add training data so that we can nudge the model to generate responses that's like human prefer. So yeah, so I think that are like those three approaches of evaluations we'll cover in the first chapter of like evaluation methodology. It also cover something very cool, like a little bit nerdy and like a pretty it really likes the topic, which is the language modeling evaluations, like cross entropy, and like perplexity. It's a little bit like mathy, and I try really hard to like get a
Yeah, but
perplexity
cross entropy and
interpretations. Yeah,
perplexity, they're actually big topics. We covered a lot of it ODSC. I think they're important for
yeah,
people to learn if they're not familiar with. Yeah, Chip,
yeah,
I really like that because the fact that 2 chapters on it, because we saw with ODSC West, all the instructors and speakers there, the retrieval augmented generation workflows are getting more complicated. The agentic AI workflows are coming online now, and in every step of those workflows, you have evaluation built into it. So it's not just about doing the evaluation at the very end, but if I have a re-ranker and my re-ranking my retrieval augmented generation results, and I want to re-rank them before I display them to the user, because we built a system for that for our VC stack, and they were not happy with the results. So I spent
yeah,
3 months of last year trying to evaluate just the ranker within that stack, and forget about the overall ranking. So again, great work on the evaluation part of it. And then I do want to take a few questions from our audience, at least one to start with. And John here has a good question. I'm going to repeat it for our podcast audience later. It's a pretty long question, so if we can display that question. And John is asking, for large companies with diverse databases and extensive domain expertise, how would you recommend they start integrating large language models effectively to leverage that specialized knowledge? So I think what John's saying here, so imagine you're in healthcare or finance, and I've been in those domains, databases and data sources, data lakehouse, data warehouse, they're all over the place. It's very specialized domain expertise. And then he's the second part to begin with. He's asking, is it better to begin with simple use cases, such as integrating LLMs from vector databases or chat, or gradually expanding to independent use cases and agents? But I think the first part of that question is really good, John, which I'll repeat. For large companies with diverse databases and extensive domain expertise, how would you start recommending these LLMs effectively? So I have an opinion on this, Chip, as I always do on most things, but you're the star of the show, so I'll let you get first stab at it, unless you want me to stab at it.
yeah. Okay, I can try to give like a quick stuff. So I think it's like if you have like extensive domain expertise, I think it's a great thing, and it's like really like it's like the advantage for the company. So I would really approach it from like two angles. one is like strategize like what use cases I want to focus on, and the second is like human resources. Like you need to like, improve the talent of the company to be able to leverage new technologies. So the first part of the use cases, and actually really like Microsoft has a framework they call like crawl, walk, run. So it start with the use cases like less risky, like low stake, like not low stake, but like less risky. So like first of all, use cases where we can actually like maybe like have a lot of human in the loop. So let's say it's like you have like customer support chatbot. I'm just throwing an example here. You can have like maybe instead of like showing it directly to like users, you have AI to generate a few options, and you have like your human expert to just pick one that like works. So that like instead of like human expert having to write from scratch, you can choose like some like pre-template from the chatbot, right? So you get human in the loop. So like when you prompt, the second is that you give AI more automations, but then you can like just use it for internal use cases so that you don't, so like maybe it's like Q&A chatbot for the employees instead of the customers. And then one is when you can show like this automation to like outside external users. And then on the other side of the angle is a human resource. Like I do think it's very important to like give their employees or staff like opportunity to like upskill themselves. Like if you just like assign them a lot of tasks, like hey, you have no time to learning, it's really hard for them to keep up to date with new technologies. So I see it's like a few initiatives by companies, like for example, like they give everyone like a free subscription to like different tool, and it's like okay, just try to use it. Like let's just try to learn as much as possible, like different training programs, just to give also like try like with like not sorry not hackathon, but like just have initiatives to get the employees, give them time and encouragement to just try, because I do think that like as a teams or like our people get better like understand technologies more, then they have a better understanding of like how to incorporate those into like building a better products for the company. Now I would
Yeah,
love to hear your perspective. Yeah.
no, I couldn't endorse that more because as an engineer last year and the year before, I rushed into building solutions very much like this, John. Vectorizing our data, which I'll get to in a little bit. But I really, what Chip is emphasizing there is so important. I really forgot the human element. And with large language models, because this is nice, we're tying back the evaluation piece. The people I was building it for were not evaluating it for me. And I wasn't getting any feedback, and I didn't upskill them. And it was a bit of a shit show, to be honest. I don't really usually swear in this, but I got a lot of grief for that. I completely dropped the ball because too often, especially with these kind of systems, we're forgetting about the human element. Yeah, on the technical side, I would say definitely check out Chip's chapter 7 on fine tuning, because I found that very useful when I read it. Because I also and if you also, John, check out our podcast, which we just released Thursday with Ivan Lee from Datasaur, and he repeated what I found myself like last year when I was trying to fine tune language models. I was spending a lot of money, and it was terrible. Like the fine tune model, because you're fine tuning those weights, the models we were fine tuning ended up with worse results than not fine tuned. So now with things like LoRa, which you got into, Chip, low rank adaptation, and then the big thing was, because you talk about domain expertise, generally fine tuning a small language model may work best. It's cheaper, they're better, and then if you look at the leaderboards, that'll tell you what the small language models are. And because the SMLs seem to be a little better at fine tuning, but again, people like Chip and Ivan Lee and Sinan, you listen to those in the podcast. They've got some great advice on doing this, like how to leverage those. But my quick take on that is small language model, read Chip's fine tuning section. That will help you understand that. And as Chip said, think about the use case, because we vectorized everything. And then all of a sudden we're like, wait, most of our use cases are time domain specific, and RAG out of the box, LLMs out of the box, they don't understand the time space continuum, I guess, very well. I know it sounds stupid, but they actually don't. When you're asking things like last week and stuff like that, because vector embeddings don't capture that. So we had to do all kinds of munging and take relational data and merge that with vector embeddings. So yeah, so you got to understand that use case, and as Chip said, start with a very simple use case. Not like me, start with a complex one, but that's good. So Chip, I think that also goes back into the next question I want to ask, because what I just said there was a bunch of mistakes I made in answering John's question. We started with too big a model. That's why we couldn't fine tune it. We tried to embed everything, which was another mistake. We didn't understand the use case. So I've named my top three. So tell us, what are the other mistakes people commonly make when building AI applications? Like, what are the future mistakes that Seamus is going to make with his team with building AI applications?
Oh, I was actually making note of what you said. It was like, wow, this is like really good lessons. I hope you write or like have a podcast about like the lessons you have personally learned from like so many of the projects. So for me, I think it's like here are a few things that I've seen, and I'm trying not to make it sound like everyone is an idiot. It's not the case. I think it's just like we are just in a pretty new phase of like AI engineering, so that it's common to make mistakes, and as we are still figuring out like the best way to do things. So the biggest mistake I see is just like people want to use generative AI for things that don't need generative AI, right? So first of all, I was talking to a few people, and they were like, hey, a team actually pitched me like, I want to use generative AI, ChatGPT, to like detect anomalies, and I'm just like, I feel like have you like tried like with something a lot simpler, like maybe like I don't know a time series, or like addition tree, like it's a lot simpler. Or like another team actually, they were like, oh, we want to use ChatGPT, like a generative AI, to like optimize for the energy usage. So what they want to do is they want to look at like the patterns of like households electricity usage, and try to like schedule it, so that, like if something is very energy intensive, should be scheduled for like when during off peak hours. I think it's a great use case, very interesting. But I'm just like, if I were to start with this, I would probably just try to look at like what are the energy consuming activities this household is doing, and just manually schedule them like during the off peak hour. So for example, you want to charge your car, maybe charge is just like when it's not like you don't need a lot of like, maybe charge is possible during I don't know, during noon, when you have a lot of electricity from like solar power. So I just think it gets that very, very simple. The second pitfall I see is that like you said, statement is like you might want to start like too complex too early. So like first of all, people maybe I start with like one of the things that people like usually try to use like very big or complex framework. So there are a lot of cool hot new frameworks, and was like, okay, let's just use it. And I do think this like level of traction is good when that attraction has been tested over time, right? But I think like now as we are still evolving, a lot of frameworks are still evolving. A lot of those frameworks have mistakes. So during the process of writing research for this book, I went to a lot of code bases, and a lot of those frameworks have like pre-built prompts, and people just use those prompts for granted. And I was just like, almost like every single of those prompts like has some typo. Like it's just straight, and like I see a lot of like commits to just change the prompts. It was like, okay, if you're using somebody like a framework and you use a prompt, and the prompt changes under you, and the application's like behavior change, you don't know what causes it. It's kind of like flying blind. Or sometimes like a lot of frameworks is like making a lot of calls you're not aware of and burning through the credits. So I think it's just like maybe like just start with something simple and just code the LM instead of like realizing on a framework. Another pitfall I see is it's like you said, in understanding like what users want, and then cannot give the models instructions like clear guideline on how to do that. There's several examples I've seen that's actually quite funny. So one example is actually from LinkedIn. So like when they were building the chatbot to help candidates like evaluate whether they are a good fit for a job, and they realize it's like a lot of time like correct doesn't mean good. So if you kind of ask like, hey, am I a good fit for the job? And the bot respond, you're a terrible fit. Then yes, it's a correct response. But like that's not very helpful as the candidate, because and they realize the candidate maybe want like pointers to help them like how to improve their profile to become better. One other examples is from like a friend working on a product that help like summarize phone calls, like summarize meetings. And at first it was like, okay, we just want to like think about like how long each summary is going to be, maybe like 3 sentences, like 5 sentences. But then it ends up like length is not the most important factor. Like what users want is that they want to know like what as an action item for me after this meeting. Like what as a key information. Like they want to know what did you do after this meeting. So like that they need to put first. So like just like some examples, like you really need to understand what the users want and then give very clear instructions with a lot of examples of like this is a good response, maybe you can, or this is a bad response. Maybe it's gonna give like explanation of why this response is good and why the response is bad, so that the models can follow the instructions to like behave in the way you want.
Yeah, wow, that's a great answer, Chip. Love all those. Um, Definitely some stuff I'm going to have to take on board as we build out our next version of our application. And just to comment on a few points you made, absolutely. Large language models or Gen AI, everyone thinks they're a hammer, and everything
Yeah.
else is a nail. I'm going to hammer this thing with the Gen AI nail. So I love your point on that. And yeah, and I actually have one, as you said, doing understanding some simple things don't need Gen AI. Like we were struggling with topic modeling because we were trying to do uh, summarization of research using topic modeling. Like we want to, okay, if we look at all the robotics research papers, what are the unsolved problems? What were the big topics in robotics in 2024? And we tried that with ChatGPT, with OpenAI and Anthropic and Llama 3. And the problem with the non-deterministic nature of the outputs, and then trying to put guardrails on top of them. Like, look, we were getting better results with just using LDA and SLA, and not even going to other like BERT topic modeling. And so, yeah, so sometimes simple techniques work really well. And and going back to John's point as well, I I really liked your chapter on data set engineering, because that to me was like a term I hadn't heard before, data set engineering. It made a ton of sense because it actually also feeds nicely into our next question, because I believe it is we have someone who's asking if we can display that question. How to improve our RAG applications? What is the best strategy and technologies for this area? So I would love if you could answer that question, but also talk a little bit about data set engineering, because you said at the very start, applications are so data centric. So I'd love to get your thought on that, Chip.
Yeah. Thank you for the questions. So I think thank you so much for bringing up this engineering. I do think it's a very important topic, and it was a really fun chapter to write, actually. Because one thing I really like about the data engineering is that it requires so much creativity. And it's just like you can be, I know it's just when I was loading through a lot of papers and how people like engineer the data set, it's like, wow, this is like really smart. So for example, like the Llama 3 paper, it has I really love the paper. And when they generate like millions of like training samples from like using like AI like to synthesize those samples. And one technique they use is just like using like code back translations. So like one important things about data synthesis is that like you need to be able to verify whether the generated data is good or not, because you know that if you train the model with bad data, the model is going to be bad. So we talk a lot about AI to generate data, but like I didn't see a lot of papers that talk about data verifications like the Llama 3 paper. So one thing they did was like code back translation. So they start from like a documentation, so like what type function they want to write. So generate the code, and then they use another AI model to like write documentation for this generated code. So now we have the like original documentations and the generated documentations, and they compare the two and say, okay, if the generated documentation is like similar to the original documentation, then they assume that the generated code is good. They're like, wow, that's like really cool. So yeah, this engineering is
Yeah.
like really fun to like learn about. Yeah, and the questions of like how to improve like the rack system, I do think it's like we talk a lot about like retrieval algorithms, like how should like get the model to be like better retrieving like context or like relevant informations, or I talk about like a lot of like better databases, like what is which one is better than another. But I do think it's like a layers like really improve the quality of a rack applications. It's like how to prepare data. so that it can be like retrieved. So like there been like a Anthropic has a pretty cool blog post on like I think it's like how they prepare data for their applications. So they also like cover like they touch on like several aspects or like several techniques will do. For example, like you have a long documentations, right? You can like start like with a summary of the document. And so when you have a long document and with RAG application, you have to chunk them, right? Like you have to chunk them. And so the problem is that like, let's say you talk about very important entity, like the company, like ODSC. And then you say, like, okay, from now what every time we will replace ODSC with like the name of like the entity, right? And then you don't see ODSC in the rest of document anymore. So you won't be able to retrieve like the other chunks, lower chunks. So like this, so somebody was like, okay, let's try like first maybe let's start a summary like of the document. So that like every chunk you like append or like prepend the summary to that chunk, or you can generate like keywords like append it so you can retrieve right informations. Also like Anthropic like use like AI to like generate like context, relevant context for each chunk. So like I think this is like this type of things like pretty exciting. Or like another team told me that they found out that like the most effective way for retrieval is like structures of data and it's a Q&A answer. Like so that's like so like it's like a Q&A chunk so that like for each request is find the questions most relevant and then they found like the answer for it. So like a lot of those like it requires work. And I do hope that like hopefully somebody out there will write like a paper or like a blog post about like how to effectively structure the data for like RAG applications. I can't hear you.
Again, Chip, I love that
Yeah.
answer because you're preaching to the choir here. Again, that was pretty much most of my 2024 was spent wrestling with our own vector database, and it's interesting. I like the way we're tying this conversation together because that goes back to again another mistake we make as engineers. Like not everything can be like embeddings are great, but they're not the solution to everything. That's one thing that we found, and how we get them to embedding and what those embedded things like a high dimensional embedding. What that can encompass is it's only as good as the data itself. So I really found that was fascinating, and I do get your point about chunking. Seems like a pretty simple thing, but tweaking that, but really your point about like I've worked with the team. We were just focusing on the retrieval algorithm, the algorithm. We were just trying to get very slight improvements where it was always about the data. When it comes to election, it's about the economy. When it comes to RAG, I know we keep repeating it, but for those people who are asking about it, it's the data, the data, the data. Everything else, you can get a little bit of uplift, but it begins and ends with the data. And that's something we really found was kind of important, even before we get into fine tuning. And then you can try perf and there's other things as well. And another thing we found as well, I'm not sure if you see this, but don't take it for granted, but our responses were just too slow. Like we had
a classic,
6-second responses, and people were like, "I'm not using this system."
Only 6 seconds? I have seen people got like 2-minute responses.
Yeah. No, it's 6 seconds. I had some. Well, I'm dealing with finance people. They are very impatient. Well, at least they want to see the what do you call that text stream first, right? So we started streaming it and doing things like that. What's our biggest solution to that was? We just cached the answers.
Yeah, no, caching is very interesting. And did you use like exact caching or like semantic caching?
Yeah, we just used very simple. We just cached it even before, because this was a year ago. This is even before these caching techniques. It was the exact same question. The data had a timing flag if the data hadn't changed, because we were batch updating it nightly, not in real time. So sometimes caching. So there could be a whole book on that question, how to improve RAG systems. So my advice is check out Chip's book. That's very relevant. And going on to another, I think is a fun topic, because I've debated this with people. I've had a few interesting conversations with people at ODSC East, ODSC West, just in November about this. And they were saying that prompt engineering is not a really engineering discipline. Because, you got to be applying systematic experimentation which I think you are in evaluation, and but you got to be applying some kind of systematic experimentation and rigorous testing to prompt design, so you can put that on par with other engineering practices. And you have a whole chapter on prompt engineering, Chip. So give us your opinion on prompt engineering.
Yeah. So, by the way, Seamus, that's independent of the question. I hope that you can host maybe like a round table, maybe a group therapy session, just talk about like mistakes like we have made in the past with generative AI. That would be really fun.
Yeah, and exactly. And John, another questions give me an idea that we're actually doing a couple of roundtables at ODSC East.
Yeah.
So no, and you can share one of those. Chip.
Yeah. Um, yeah, I do have a lot of lessons. But by the way, for the question of like prompt engineering, whether it is a serious engineering discipline, I think it can be. I think just like prompt engineering, it's not that it really depends on how you do it. And some people are definitely more systematic than others. And I do think it's like we can make prompt engineering like pretty systematic. So first of all, you can version a prompt. You like I already said, right? Like like we already know like about experiment tracking from like classical machine learning engineering, and we can do the same with like systematic like you consider like each prompt changing, version changing is an experiment, so you can track the progress. And also like about evaluations and also follow the engineering like this from engineering best practice, or like having a way to like essentially like have a prompt repository so people can reuse and like reshare your prompt. I do things that a challenge with a lot of teams that I've seen, like maybe it's a common mistake, is that people decouple the prompt from like the applications. So an example is like a lot of people use AI as a judge, right? And an AI judge also has prompt. So that like this person, so like you have like I talked to the team, a pretty big company, so they have a team that's work on like metrics, so building AI judges, and they have downstream teams to like the applications and use those metrics to
Oh,
evaluate their
they
applications.
build their own judges. Wow, that's cool.
No, so they develop like maybe like fine tune or like they write
Oh,
create like
fine tune. Yeah,
prompts like
judge.
yeah.
Yeah.
Yeah. So I talked to like one of the PMs, and he was just like, "Oh, for application, we do check it very rigorously. Like we notice like this score is improving. So like first of all, like faithfulness is like improving." And I'm just like, "Okay, so what is the prompt you use for the judge to evaluate faithfulness?" And he was like, "Oh, we don't know. Somebody else does that for us. So they never see the prompt for the judge." And I'm just like, I think like if you use AI as a judge, you need to be very skeptical. Like, you need to be like very you need to know like what the judge is, right? Because and let's say it's like the metrics team like change the prompt for the faithfulness judge, then maybe the score will change, but you don't know if the user applications or it's because the judge behavior is now different. So like it's very important to have transparency about around the space for like prompt.
Yeah, I think that's very, very valid. Um, and again, yeah, AI is a judge, LLM is a judge. I love how much depth, how deep you're going on that, Chip, because that was another very, very important topic for all of 2024, and I think that's going to be so important going forward. And because we're working on
Yeah.
those as well, it's a fascinating topic. I do want to take another
Yeah.
audience question before we get into our wrap up questions, Chip, because I know we're coming up to the top of the hour. But let's see here. So what's your recommendation for start building new LLM models with minimal GPU hardware resources, especially on private data? So that's a great question. I'm not sure if they mean building a new LLM model from scratch, because for that, my recommendation would be no, don't do that.
I mean, I
I
would
think they
not
might
say,
mean fine
yeah,
tuning, but go ahead, and I might
yeah.
take a stab at it as well.
Yeah, I think it's like maybe you can take a stab at it, because when I look, it's like starting a new model is like
Yeah,
how much
I
money
don't
have
think
you
it's so much.
raised?
Yeah,
Yeah.
like I would say the first recommendation is definitely don't try and build a new large language model, because that is still very expensive. Definitely, as from what I've seen, prescribed best practice and what we've done is fine tune an open source model. So even though you're working on private data, it's okay to fine tune. It's actually better to fine tune it, because if you have private data, you should not be sending your data across the internet to these private, very large foundational model companies, because doesn't matter what they say on the terms and agreements. You have your own company, assuming it's company data, right? You probably don't have permission to send it across. So definitely working with an open source model would be the number one recommendation. I think one of our guests recommended start with the best model, even though it's the largest model, but that was counterintuitive because if you want to fine tune, you might be better off starting with a small model, as we mentioned earlier. Maybe Chip, you're more better equipped to answer that question. And then I would say my last point on that would be definitely low rank adaptation, low rank and what's it called? Yeah, parameter efficient fine tuning is a big one. And as Chip, you mentioned, I find, yeah, I think we fall into this trap of with large language models, like more is better. No, like a high quality curated data set in your data set engineering, which you talked about, is much more effective. And then I've tried not a mistake, but what is it? PyTorch has a very good quantization library where you reduce a 32-bit down to a 4-bit or even a 1-bit. I've had mixed results with that because it allows you to train faster on your GPU, because it's not so much the GPU, but how much time you're spending on those GPUs. And like, Hugging Face has got some good resources for this. TensorRT, I think, does that as well. We looked at that. There was some pretty good frameworks, and definitely smaller language models. And then, and I do know certain certain cloud providers are providing, like, HIPAA compliant data. They are starting to build that out. And then my last kind of trick here would be, not trick, but recommendation is use tools like weights and biases. It's a free open source tool that allows you to monitor how the training's going, so you're not burning dollars. So sorry, Chip, that was more of a list of pain than an answer.
Yeah. No, I do think it's like if you train model or fine-tune models, there'll be a lot of pain. And I think a common I often hear is like the actual fine-tuning process is actually easy. Like you said, like there's a lot of like frameworks, open source is great.
Yeah.
And there's so many available models out there to try. The hard part is to like get the data to like fine-tune the model. And then after you fine-tune a model, you need to think about like how do you serve the model, right? Because now you have this model sitting somewhere, and like inference optimization is like really hard. Like how do you like optimize a model to run fast and cheap? And then like how to keep up to date with new progress. Let's say you fine-tune the model on top of model X, and tomorrow there's like X 2.0 like comes out, right? Like do you fine-tune on top of it? Like there's so many new models coming out. Like how to keep up to date with all of this can be quite challenging as well.
No, the inference one's a very good point, because even if you run an open source model, running those open source models is definitely not for the budget conscious, so to speak. Yeah, and one quick plug: do check out my podcast with Ivan Lee, because he's got a great startup with a great platform called Datasaur, and allows you to do all these steps very, very quickly. So if you're thinking about doing your own large language models, fine tuning them, and you're not familiar with it, I'm not saying using Datasaur or a platform like that will be your end production solution, because as Chip said, hosting these models is kind of a very interesting topic, but it'll give you a good idea of how fine tuning works. You can do it very cheaply, because start small, start with a very simple use case. Don't start with all your data, but that's a good way of starting with it. All right, so Chip, I want to ask a few. I don't know. I guess one very essential question. Well, like you wrote about so many great topics in this book here. Chapter 10 is on AI engineering, architecture and user feedback, which you touched upon, data set engineering, fine-tuning, RAGs and agents, prompt engineering, evaluation, understanding LLMs. What was the hardest thing to write about in this book?
I think it's like everything was hard in its own way. So I think my first like structure the book is like really, really hard. And also one thing like so for me like writing. So I thought about like what is the meaning of like what is the goal of writing or like teaching? Like because I used to take some courses at my last university. So and I think it's just like nowadays like if you have a question, it's usually easy to like find the answers online. right? Like if you first of all you ask for a definition, you can ask ChatGPT to like come up with like 1,000 ways to explain the definition for you. But like what is really hard is to come up with the right questions. So it was just like, yeah, okay, like how do I focus on asking the right questions for my book? And that was like really, really hard part because yeah, so I spent a lot of time like talking to a lot of people, and like the structure of the books like to highlight those questions and then answer them in like a systematic way, but still like following some kind of like flow and structure. And so like some chapter was a hard to write, like evaluation chapters, the two of them. The first one on methodologies, and the second one on like how to use those methodologies together to evaluate an AI system. It's just like it went through so many iterations. It was like so painful because it was hard. So I
Wow.
hope yeah. So another one is like so challenging because I'm not really that deep into it. First of all, like inference optimization, like system stuff. Like I did need got a lot of help like with that chapter. Other chapter like user feedback is hard because it's a pretty new. Like people don't talk about it. Like we know that user feedback is very important. Everyone want to have a data flywheel, right? You want to feedback from the user to improve our systems, but then we see like conversational feedback, like for example, like so what I mean by user feedback is or conversational feedback is that when you talk with a chatbot, you can embed like blend the feedback into conversations. So first of all, like you ask a chatbot something and it's like, oh, that's too long, right? And the chatbot should know how to reduce it. So like one of this, like you need to be able to extract those from like the natural conversations and then how to like use that to train like to improve those application. So it's hard because I don't people are not talking about it enough yet. So like there are a lot of it not available for AI. And then so I had to like, look into like other field. First of all, like how does natural feedback is being used in actually train voice assistants because that had been around for a while, and especially in the reinforcement community, like how the reinforcement learning community has been using natural language feedback to like improve algorithms. So yeah, so they are on hard in different ways. But thanks for asking that question.
Yeah, I'm just browsing that chapter again on user feedback. Some great stuff in here, which unfortunately we don't have time to get into because we're running out of time. But I have a question for you, and I've got a question for our audience as well. Let's since it is the beginning of 2025, and again for our audience, if you can share what you're excited about in 2025. But Chip, what are you excited about in 2025? Apart from ODSC
Well,
East and ODSC West.
well, you have to invite me again. So yeah, so I think like the more so thing I'm more excited about is like more drama from OpenAI. It has been like
More
very
drama
and
at OpenAI. Nice, nice.
yeah. So
More
I'm
Elon Musk drama, more
yeah,
OpenAI drama.
yeah, we're gonna have a new president, right?
Yeah, yeah.
So yeah, it's a
That's going to be a
new
lot of
yes,
drama all by
it's,
itself. It already is, Chip.
yeah,
Already is.
yeah.
But I asked, you're not answering the question. I asked you what you're excited about for 2025.
Oh, like personally about
No, no, no.
AI.
I'm only joking. I'm only joking. So
Yeah.
what are you excited? What are you excited about for 2025 in the world of AI?
Yeah, so I think it's like more applications. I do think that we are getting a better understanding of how to build successful AI applications. So I do see just like many more, and I think like people probably are sick of hearing the word agent, but I do think it's like the capabilities of models with like more tool use and better planning capabilities, and then we just have a better understanding of how to like evaluate and build the applications to leverage and to interact with the real world and like as the internet, but like to perform like real world tasks. I think it'll be very exciting. I'm always excited about like compute. So I want to see more. I think NVIDIA is a very interesting company. Like I just realized it's like one of those big companies that don't really have drama. So yeah, and this is like maybe like more fluctuations on the stock prices. But I would love to hear more to see more of like new kind of like compute hardware architectures. Because GPUs have been dominating for a while. So I'm not sure like until when we can see like a viable or like alternative to GPUs. But that could be very exciting. Yeah, I think that's this just
Yeah.
a few off the top of my head for now.
I guess you were saying about NVIDIA. Outside of ODSC, the NVIDIA GTC conference in San Jose was always my favorite conference. I've been going to those, I don't know, for the last 11 or 12 years with COVID accepted.
Yeah.
And I always thought it was too gamey focused. And I knew
Yeah.
AI was coming. And I never bought enough NVIDIA stock. But anyway, shoulda, coulda, woulda. Shoulda, coulda, woulda.
Yeah. And everyone probably has regrets.
And just to that point about agentic AI, like again with our podcast with Ivan Lee last week, he said agentic AI is a fantastic marketing term, and all it is a small piece of software that can connect to an API, which is right. But we also had I think it was episode 74. We did this about a month ago. It's on our podcast. We had this podcast called Open Agents with Robert Brennan from Open Hands or All Hands. I think he's calling it All Hands AI. And if you're interested in agents for our listeners, go check that out because it's a very popular open source framework. And I've been playing around with it. It's kind of, yeah, it's good.
I really love how supportive you are open source and like pulling out on this cool open source repos.
You gotta be, because you know, this is how you learn and practice, and then you go, someone pays you for those skills, right? So
yeah.
All right, Chip. So how do you manage to do what you do? Because I speak to a lot of people who write books and stuff like this, but how do you give us the Chip Huyen tips on staying abreast of the latest development in AI? What's your superpower? How are you so awesome?
Wow. Well, you should really tell my mom that so she can stop nagging me. So I think it's like I do think it's like writing this book was not easy, and I could have not been able to do it without the help of like so many people, like a lot of people. I'm not sure so the acknowledgement of the book. There's a lot of people that helped me, and they were extremely kind. So I think it's like the secret is just to surround yourself with people smarter than you. So so I don't usually read news. I feel like whenever there's some news flashing, I find it very distracting. So I tend to so I don't really pursue like okay, what is the hottest things out there? But it's more like, okay, what seems like the most interesting? So like I focus on more the problems that I want to solve, and then I want to see like, okay, what actually helps solve this problem. And then I also talk to friends, and I have this heuristic of like, okay, if like three of my smart friends mention something, then I should definitely look into it. Or like another heuristic is just like the Lindy's law. It's like say that's like the future lifespan of like something you can approximate to be like equal to its existing like lifespan, like how long it's been around. So a lot of things that's been around for only a week, we can assume that it will be around for another week. So like just keep on chasing like hypes and news. It's very easy to get sucked into like things that's like eventually don't really matters and get very very overwhelmed. Yeah. So
Let's get into that because it's time for New Year's resolutions, right? But Lindsay's law, did I pronounce it right? Lindsay's law. Lindy's law, because I actually never heard that before, and I've been in tech a long time, and it was in your book, and I was looking at it the other day. I was like, oh, this is very cool. So so check out Lindsay's law because I think that's very relevant, whether you're being a tech person or even investing. I like that one, and I do love that superpower. Expand your network. That's why people should come to ODSC because that's why we started. And that's why we started meetups. Like we're still hosting. We're hosting meetups in Boston, New York, DC, San Francisco, and I go to them. And we don't make any money from meetups. In fact, the funds we get from ODSC help us pay for the staffing and the help of the meetups. And Ira, who's listening in this conversation, is probably smiling. But we love meetups because it's all about building those networks. Because Ira actually organizes all these fantastic meetups for us around the world. So so surrounding yourself with I have a hard time surrounding myself with people smarter than me because most of my friends like to drink and play golf. So that's that's a challenge.
They're smart in a different way. I mean, like they know how to enjoy life.
Yes, they are. They're usually better than golf to me because they have more time to golf and actually they got more time to drink as well. But in all seriousness, like I honestly believe that like surrounding yourself with a good network because I see it time and time again. People I haven't heard for in 4 years. Seamus, I'm looking for a job. Can you help me? I'm like, dude, who are you? Why are you asking me now? like have a network. It's so important to have a network. And yeah, and that's actually one of my resolutions, is not to pay attention to the news, because someone much smarter than me said that to me. He's like, look, there's no point in catching up with the news every day, because the new stuff that matters, you'll be able to catch it up like once a week. And focus on your own stuff. And especially for those of us who work from home and remotely, it's very easy to get fallen down news traps. So how can people so last question, I promise, Chip, how can people, so yeah, so check out Chip's book. Please take a look at that. It's worth the price of admission, I'm telling you. And also some of the best blogs I've written and I've read in the last year or two, Chip, I've read from you. Some of your blogs in open source are phenomenal. So how can people follow your work? You still have your website?
Yeah. So my website, my Twitter, LinkedIn. I'm like not that. Yeah. So website and social media. Um, yeah.
Excellent. What I'll do is I'll include those in the show notes. And Chip, thank you so much again. I'll see you at an ODSC conference
Yeah.
in this year. And thanks again for being so generous with your time. And thanks for doing such a service to the community by giving talks, writing blogs, and writing. I'm telling you, I don't often say this because people listen to me on the podcast. Like I've read some good books, but this was an amazing effort. So job well done, as we like to say. Job very well done.
Thank you so much. It made me very happy to hear, because writing a book is like a little bit of like very like it's scary, right? You write for a long time, you don't know how we're gonna perceive it. So I really appreciate the kind words. And also thank you so much for having me, and thank you everyone for tuning in. And I really hope to see you at ODSC this year.
Okay. Bye, Chip. Bye for now. Thank you, everyone.
Bye,
Bye
Simon.
bye.